Hello, this is A-level mathematics with Mr. Ayo. We want to continue with the series. The topic I'm looking at is differential equations. Differential equations. In this topic, we are going to make use of the concept that we have learned under integration and differentiation, the integral calculus and the differential calculus, because we are going to be using the concepts under these differential equations. So I'm going to quickly do a recap of a summary, of the important formulas under this topic before we continue. So function differentiation. And again, function integration. So now when we have y is equal to ax raised to power n dy dx, this n, the power will multiply the coefficient, that is an, then you now minus 1 in the power an, then x raised to power n minus 1. So if you differentiate ax raised to power n, we get an x raised to power n minus 1. And of course, you know the rest. When you differentiate sine x, you're going to get cos x. When we differentiate cos x, I'm going to get sine x. And we differentiate tan x, I'm going to get sec square x. When you differentiate sec x, I'm going to get sec x tan x. Now, when we differentiate exponential x, I'm going to get back exponential x. This is very, very important. When we differentiate arc sine x, it's going to give us 1 over square root of 1 minus x squared. When we differentiate arc tan x, I'm going to get 1 over x squared plus 1. So now, integration is the opposite of differentiation. Okay? Integration is the reverse of differentiation. So if you want to get integration, you just come in you turn this one to this. So if I'm integrating ax raised to power n, you know, in differentiation, you first multiply the coefficient to the power, then you minus 1. But in integration, what you do first is that you add 1 to the power. You add 1 to the power. You add 1 to the power, you now divide by the answer. For example, let me do this. Let's say that I will be using this one to get this one back. Now, if I want to integrate this one now, I want to integrate an x raised to power n minus 1 dx. I'm going to add 1 to the power. I'm going to give me n minus 1 plus 1. N minus 1, n minus 1 plus 1 will give you what? N. So it's going to give me n. Then you will now divide this one by the n. When you divide by the n will cancel n. You're going to have left. You're going to have, it's going to give us, see what I'm saying? It's going to give us an x is power n minus 1, then plus 1 over n minus 1 plus 1. Minus 1 plus 1 will cancel. So it will remain only this will cancel this. The same thing there, this will cancel this. So this n will also cancel this n. At the end of the day, what I'm going to have left is ax raised to power n. So that means when I integrate this, I'm going to get this one back. I'm going to get ax raised to power n plus c. Okay? If I integrate cos x, I'm going to get minus sin x. Now, don't forget, if I differentiate cos, it's minus sin. But if I integrate, if I integrate cos, I'm going to get sin x. Get this one back. If I integrate sin x, because of this minus, I'm going to get minus cos x plus c. Okay? If I integrate sec square x, I'm going to have tan x plus c. If I integrate exponential x dx, I'm going to have exponential x plus c. Okay? If I integrate if I integrate 1 over square root of 1 minus x squared, it's going to give me arc sin x plus c. If I also integrate this one, 1 over x squared plus 1 dx, it's going to give me arc tan x plus c. So you can see that integration is the reverse of differentiation. So once you master this one, you don't need to cram this one again. Once you can master this one, you can easily remember this one. Okay? Now there is one I have not added. I'm going to quickly add it. Let me put it here. There's one I need to add. Okay? Because we are going to make use of all this as we continue this series. Now, when we differentiate, that's what we call log x to base e. We also call it ln x. Anytime you differentiate log x to base e or ln x, it's going to give us 1 over x. Anytime you differentiate ln x or log x to base e. What you get is what? 1 over x. So anytime you don't forget that integration is the reverse of differentiation. So if I now integrate this 1 over x dx, it will give me back this one. It will give me back ln x, which is also called log x to base e. Please don't forget, we are going to be using all these concepts as we continue in this topic. So this is just like to make us remember the basic concepts, the basic formulas of both differentiation and integration. Alright, so okay, so for today's class, we will continue with how to form differential equation. Okay, in the first series I solved one question, so today I'm going to do another example today, and that is okay, form differential equation with y is equal to x over square root of a squared minus x squared. So this is what we want to look at today. We want to form a differential equation with this function. Okay, now if you look at this function, this is like division. We have a numerator and denominator. You know, under differentiation, if you remember, we have chain rule, we have product rule, and we have quotient rule. Okay, you use chain rule when you have a function like this raised to power n. You use product rule when you have two functions multiplied together, and we use quotient rule when we have division. But I prefer using product rule when I have two functions. Okay, so for this question, I'm going to apply product rule. So how do I do that? I have to take this one up. So I will turn this one to y is equal to x into a squared minus x squared raised to power minus half. Using indices, this square root is raised to power half, but because it's down, I've taken it up, that we call minus half. So now I'm going to apply product rule. I hope you remember product rule. Product rule says when y is equal to u of x times v of x, we do dy dx is equal to u dv dx plus v du dx. That's the formula of product rule. So this will be my u and this will be my v. I'm going to use u dv dx plus v du dx. So I'm going to do dy dx is equal to, this is u now, this is u d of dx of a squared minus s squared raised to power minus half, then plus v, this is my v, a squared minus s squared raised to power minus half, then d of dx of x. Please, are we getting it? Okay, so I'm going to differentiate now. Now, if I differentiate a squared minus s squared plus power minus half, this function you are saying, to do it, we are going to use chain rule, because it's under this. And how do you do chain rule? You first differentiate what is inside here. Okay? When you differentiate what is inside here, this is a is a constant. When you differentiate minus s squared, it will give you minus 2x. It's going to give you x times minus 2x into, then remember the general formula of differentiation. When you are differentiating x is equal to n, it will be nx is equal to n minus 1. So this minus half, we use to multiply the coefficient, then you now minus 1 from the power. So into a squared minus x squared plus power minus half minus 1 will give us minus 3 over 2. Okay, then plus. So I've done this now. Now I'm going to move to the side. If I differentiate x, it will give me 1. So 1 times this. So you have a squared minus s squared plus power minus r. Okay, so let's go and simplify it. 2 cancel 2, minus times minus plus, then x times x, so this will give me dy dx is equal to 2 cancel 2, so you have x squared into a squared minus s squared plus power minus 3 over 2, then plus a squared minus x squared plus power minus half. Okay? So I hope you are following. Don't forget, we are forming differential equation with this function. Actually, we are going to form a second order differential equation with the function. So let's move on. Now, I've gotten, this is my first order. This is the answer for the first order. Alright? So please, let's keep this. Don't forget it. Now, I'm going to proceed further. I'm going to do the second order. What does that mean? I'm going to differentiate this function again. This is s squared times another function. So I'm still going to apply product rule here. I'm going to be u, this will be u, this will be v. So I'm going to have x squared d of dx of a squared minus s squared plus power minus 3 over 2 plus a squared minus x squared plus power minus 3 over 2. I will now differentiate s squared d of dx of x squared, then plus this one is just one function, so I will just apply the general formula of differentiation, which is bring this minus half to multiply the coefficient, then remove 1 from the power. So I'm going to have minus half, then into, then I have to differentiate what is inside here. That will give me what? Minus 2x. And I'll now write everything. A squared minus x squared minus half minus 1 will give me minus 3 over 2. Okay? Now, the next step, I'm going to differentiate this one, and that will give me x squared If I to differentiate this is we are going to apply chain rule, which we call function of a function. Bring the power, this minus 3 over 2, bring it to the coefficient side. That will be minus 3 over 2. Differentiate a square minus s square. That will give us minus 2x. Then you write this again, a square minus s square, and you now minus 1 from this power. Minus 3 over 2 minus 1 will give us minus 5 over 2. Plus, of course, if I differentiate s square, I'm going to give me 2x. So 2x into a square minus x square is for minus 3 over 2. Okay? Now this one minus times minus will give me plus. Okay? 2 will cancel 2. So this one will give me x into a square minus x square is for minus 3 over 2. Okay? You are getting there. This divide dx, please, I'm not going to clean it because I'm going to use it. So I'm going to use it. So just note it. Okay? I'm going to use this divide dx as we move on. So from here, I'm going to continue again. So let me clean here. This one, just note it. I'm going to leave it because I'm going to use it. Alright, so the next thing now is we are going to simplify our second order. The square y over the s square is equal to, okay? Look at this. Minus times minus is plus. 2 will cancel 2. So this will give me x squared times x times 3. That will give me 3x cubic into a square minus s square this part minus 5 over 2 plus, if you notice, this and this, they are the same thing. This and this is the same thing. So I can just do 2x plus x, give me 3x into a square minus x square this part minus 3 over 2. Alright, I think we are getting there as possible. Now, what we want to achieve is that we want to bring out this first order from here. So what can we do? Look at this. We have this is minus 3 over 2. This is minus half. Okay? Okay, what can we do? Now, minus 3 over 2. Now, if you do minus 3 over 2 minus 1 over 1, 2 into minus 3, 1 into 2, so I'm going to get minus 5 over 2. Now, you agree with me that this minus 5 over 2 minus 5 over 2 is the same thing as minus 3 over 2 minus 1 over 1. Okay? You see, this 1, 2, this minus 3 over 2 is the same as this minus 1 over 2 minus 1 over 1. You can try it. If you do minus 1 over 2 minus 1 over 1, the LCM is 2. 2 times 2. 2 in 2. 1, so you have minus 1. Minus 1 in 2. 2 times 1. So you have minus 3. So you can see now. Minus 5 over 2 is the same as minus 3 over 2 minus 1. Again, minus 3 over 2 is the same as minus half. So I'm going to this one, I will replace it with this. I will replace this one with this. Okay? Just watch what I'm doing. Alright. So I'm going to turn this to the square y over the x square is equal to 3x cubic into minus x squared raised to the power minus 3 over 2, and another one h squared minus x squared raised to the power minus 1, and plus again turn this one to 3x into h squared minus x squared raised to the power. This one will give me minus half, then again I will have minus 1. Remember, minus 3 over 2 minus 1 will give you this one back. Minus half minus 1 will give you this one back. Alright. The next thing is we will now bring out the common factor. The square y over the x squared. 3 is common here. X is common here. Then this one is common. So we're going to bring out 3x. This one too is common. 3x into a squared minus s squared raised to the power minus 1. Okay, it's common. So this one will remain x squared into a squared minus s squared raised to the power minus 3 over 2 plus, don't forget I brought out 3x, okay? 3x and this one, so remain only this one, a squared minus x squared raised to the power minus half. Alright? So, if you look at it very well, this is the same thing as this. This is the same thing as this. So I brought out the y dx inside here. So I'm going to have the square y over the x squared is equal to 3x. This one can come down over a squared minus x squared. Now the whole of this is your dy dx. So dy dx. Alright? Now if I cross multiply, now since I've made use of this one now, I can plane it. I can plane it now. And don't forget this, the whole of this is dy dx. Alright, so if I cross multiply, I'm going to have h squared minus x squared, the square y over the x squared is equal to 3x dy dx. So you can give your final answer as h squared h squared minus x squared dy dx minus 3x dy dx is equal to 0. So this is the final answer of the differential equation. The differential equation of that function. Remember the function. So this is the differential equation of, remember the original question, x over square root of a squared minus x squared. I think that's the original question, right? Yes. So this is the answer. This is the differential equation of the function. So please, I hope you enjoyed the class. So as I said, this is going to be in series. So this is part 2 of this differential equation. Please, if you have any students in university that is offering differential equation, just encourage them to join my YouTube link. It's good. This is going to be like 20 series. So this is the second part. Watch out for the next part. Thank you.